In this video, let's see the topic on bearing capacity from insitu test. First of all, myself B. Chalapriya, Assistant Professor Civil, Rohini College of Engineering and Technology, Palkulam. So, insitu test. By conducting an insitu test, the bearing capacity are to be determined. So, what are the tests? Means standard penetration test, cone penetration test, and a plate load test. Standard penetration test is denoted as SPT, and cone penetration test is represented as CPT. So, first one is standard penetration test. Standard penetration test is a in-situ test and it is conducted in a borehole. By conducting this test, we can determine the resistance value of soil strata to penetration undergone. So, by conducting this test, we can useful to determining the relative density, angle of shear resistance of cohesionless soil and compressive strength of cohesive soil. So, the requirement to conduct SPT are spittoon sampler, drop hammer, drilling rod and driving head. So, this is a picture. You can able to see that there is a borehole. Above that, the drilling rod. The drilling rod is attached to a driving head, and above that there is a hammer of weight 63 kg and it is free fall of height 750 mm. So, procedure. First of all, this test is conducted in borehole. First, the borehole is made by using a drilling rod. By drilling a required depth, the drilling rod is removed and sampler is attached, and above the sampler a hammer is raised to free fall of about 750 mm until the penetration of about 150 mm. The number of blows is 30 blows per minute as per IS 2131-1963. The number of blows of hammer required to drive up to a depth of 150 mm is recorded, and again 150 mm penetrations. The number of blows are to be counted, and further one more time for 150 mm penetration the number of blows required is counted. The first 150 mm penetration blows counted are to be negligible, that is not considered. The last 150 mm penetrations, the number of blows are to be added and to give the standard penetration number. So, due to this there is a two corrections may be made. First one is dynamic corrections and overburden pressure. Dynamic corrections, the connected penetration number is NC equal to 15 plus 0.5 NR minus 15. Here NR is a recorded value and NC is a corrected value. Next one is overburden pressure. Here overburden pressure value NC equal to Cn into N. Here Cn is a correction factor for the overburden pressure. So, next one is cone penetration test. So, cone penetration test is a simple and portable. It consists of a hardened conical tip standard steel rod and a weight hammer of about 6 kg. It is dropped from top of the rock against an anvil to inserting a cone into the ground. So, apparatus required for DCP are handle, drop rod and hammer. So, first of all, the instrument is held vertically and weight is raised carefully and allowed to free fall. So, due to the different strata, the number of blows between the stratas are to be varies and it is to be recorded. And it is advised to take the reading as an increment of about penetration 10 mm. So, for good quality granular basis, the reading for about 5 or 10 blows. For loose, that is weak soil means the readings may take 1 or 2 blows may be appropriate. So, next one is plate load test. Plate load test is conducted to determine the allowable bearing pressure, and it is conducted by using a plate. So, first we want to make a pit, that is hole of size 5 BP cross 5 BP. BP is nothing but width of a plate, test plate. So, first by driving a pit, then we are making a center hole of BP cross BP, that is width of the plate. Here dP is calculated by the following relations, that is dP by BP equal to dF by BF. Here dP equal to dF by BF into BP. Here where BF equal to width of the pit and BP is size of the pit. So this is a plate load test setup. Here bottom there is a dP, depth of the pit, that is hole, and there BP is a test of a plate, and above that the column is to be constructed, and above that a steel girder, that is a rigid plate platform, are to be made. So for conducting a plate load test, for applying a load there are two types. So first one is gravity load test and second one is reaction test method. So gravity load test means here a sandbag is used above the rigid plate for transferring a load. So this is a figure you can able to see. Above the rigid plate there may be a placing of sandbag. So next one is reaction truss method. In reaction truss method, the reaction generated through the jack by reaction truss. So the undesirable moment caused due to the reactions of truss is controlled by an angle, which are fixed into the soil with the help of hammer. So this is a figure. Next, first we want to excavate a desirable pit. Then a test plate is placed at the center of a pit, and above that a column is placed and load is transferred to the plate through a centrally placed column. Here the load can be transferred to the column either by a gravity load method or reaction truss method. In gravity load method means we are made a platform to construct over the column, and load is applied by means of a sandbag or any other dead load, and a hydraulic jack is placed in between to them to transfer a load gradually. For reaction truss means we are constructing a truss above the rigid plate. Next, two dial gauges were attached diagonally corner to the plates to record the settlement of a plate by the applications of load. So first we want to apply a seating load about 0.7 kN per meter square and releases before the actual loading start. Next, the initial readings are to be noted, and load is then applied through the hydraulic jack. The increment is generally 1/5 of the expected safe bearing capacity or 1/10 of a ultimate bearing capacity. Then the settlement are to be observed for each increment from the dial gauge by hour basis such as 1, 4, 10, 20, 40 and 60 minutes, and then a hourly intervals until the rate of settlement is less than 0.02 mm per hour, and readings are noted in a tabular form. After completing the collection of the data for a particular loading, the next load increments are to be applied and readings are noted until the new load. And the maximum load is generally 1.5 times the expected ultimate load or 3 times of expected allowable bearing pressure. So by conducting this test we can able to find the bearing capacity, also settlement. So first one is bearing capacity. So for sandy or gravel soil, QF equal to QP equal to B by BP. For clay soil, QF is approximately equal to QP. For C5 soil, capital Q equal to Q into A plus PS. Next one is for determination of settlement. For clay soil, SF equal to SP into BF divided by BP. For sandy soil, SF equal to SP into BF into BP plus 30 the whole square divided by BP into BF plus 30 the whole square. So next one is limitation of plate load test. So before conducting a plate load test, there is some limitation, depends upon the size effect, scale effect, time effect, interpretation of failure, reaction load and water table. So next one is advantage of plate load test. So by conducting a plate load test, we can able to evaluate the action of base under the loading actions and soil capabilities and time and cost effect and easy to executive. Disadvantage of plate load test: the depth of impact is small and the scale of test plate is smaller than the real base, and significant land disturbance happen after drilling is finished. So in this video we see that first one is standard penetration test, cone penetration test and plate test. Thank you.